November 8, 1942. Kummersdorf Proving Ground, 25 miles south of Berlin. Oberst Heinrich Müller stood in the cold morning air of the weapons testing facility, his breath forming small clouds as he watched a wooden crate being pried open by two Wehrmacht technicians. Inside, wrapped in American canvas and coated with a thin film of Cosmoline preservative, lay 6 M1 Garand rifles captured 3 weeks earlier during the Allied landings in North Africa. Müller had spent 23 years in the German army. He had carried a Gewehr 98 through the trenches of the Great War. He had overseen the development of the Karabiner 98K that now equipped every German infantryman. He had examined captured Soviet, British, and French weapons, always finding them adequate but unremarkable, confirmation of German superiority in small arms design. He expected this American rifle to be no different: simple, functional, probably crude in its execution. He was about to discover he was catastrophically wrong. Within 72 hours, after German weapons experts had completed their analysis, several senior officers would walk out of that facility and tell their colleagues something that bordered on treason. The Americans have solved a problem we didn't even know existed, and they've done it so completely that our infantry doctrine is already obsolete. One of them, General Major Kurt Fischer, who had commanded infantry divisions since 1939, would allegedly return to Berlin and request an immediate meeting with the Army High Command. When asked what was so urgent, he simply said, "Because if we don't change everything about how we arm our soldiers, we're going to lose this war one rifle at a time." What could they have possibly discovered in a handful of rifles, standard issue weapons among millions, that led to such a devastating realization? Stay with me, because the answer reveals one of the most profound shifts in infantry combat that occurred during World War II, and it happened so quietly that most people missed it entirely. Before we understand what those German officers found, you need to understand what they were looking at, and more importantly, what they believed about infantry combat. The M1 Garand was the world's first standard-issue semi-automatic rifle. 8 rounds of 30-06 Springfield ammunition fed from an en-bloc clip that ejected automatically when empty with a distinctive ping that would become legendary. Weight, 9.5 pounds. Length, 43.5 inches. Effective range, 500 yards with iron sights. American soldiers loved it. General George Patton would later call it the greatest battle implement ever devised. But in November 1942, it was still relatively new to combat, and German intelligence officers had only fragmentary reports about its performance in the Pacific theatre. What they knew suggested an interesting weapon, perhaps even impressive by American standards, but nothing that would fundamentally challenge German military thinking. Here's what the German officers expected when they got their hands on these rifles. They expected American pragmatism, adequate engineering focused on mass production rather than precision. They expected shortcuts, simplified designs that sacrificed performance for manufacturing efficiency. They expected, if they were being honest, something inferior to German craftsmanship. The standard German infantry rifle, the Karabiner 98K, was a refined evolution of the Gewehr 98 that had served so well in the previous war. It was a bolt-action rifle, which meant after each shot, the soldier had to manually work the bolt to eject the spent cartridge, chamber a new round, and recock the firing mechanism. 5 rounds loaded from a stripper clip. Reliable, accurate, and built to the exacting standards that German engineering demanded. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Karabiner 98K represented the culmination of decades of bolt-action rifle development. German soldiers could fire perhaps 15 aimed shots per minute if they were well-trained and experienced. The rifle could reach out to 800 yards effectively in the hands of a skilled marksman. It was, by any objective measure, one of the finest bolt-action military rifles ever produced. But here's the critical assumption that shaped German thinking. Bolt-action rifles were what infantry combat required. German doctrine emphasized marksmanship, fire discipline, and the concentrated firepower of machine gun teams. The rifleman's job was to provide accurate, controlled fire, while the MG-34 and MG-42 machine guns delivered the real killing power. This wasn't just German thinking. It was universal military doctrine. The British used the Lee Enfield, another excellent bolt-action rifle. The Soviets had the Mosin Nagant. The Japanese carried the Arisaka. Every major military power had concluded that bolt-action rifles represented the optimal balance of accuracy, reliability, and battlefield utility. Semi-automatic rifles had been attempted before. The Americans had experimented with the M1 941 Johnson. The Soviets had the SVT-40. But these were specialist weapons, issued in limited numbers, prone to problems, complex to maintain. The conventional wisdom was clear. Semi-automatic rifles were interesting in theory, unreliable in practice, and unnecessary for infantry combat anyway. So when these 6 M1 Garands arrived at Kummersdorf, the examination team approached them with professional interest but no real concern. Document the design, identify weaknesses, understand American manufacturing methods, and move on. They had no idea they were holding a weapon that had already made their own infantry rifles obsolete, even though most of the German army didn't know it yet. Hauptmann Ernst Weber, Kummersdorf's chief small arms evaluator, began the examination the way he always did. Visual inspection, noting construction methods and material quality. He field-stripped the first Garand, carefully removing the trigger assembly, extracting the operating rod, separating the bolt mechanism. His practiced hands moved with the confidence of a man who had disassembled thousands of weapons. And then he stopped, really looked, and felt something shift in his understanding. The quality was extraordinary, not good. Extraordinary. By November 1942, German weapons production was under increasing pressure. Demand was rising as the Eastern Front consumed men and material at unsustainable rates. Shortcuts were being implemented. Stamped parts were replacing machined components. Finish quality was being sacrificed for production speed. Experienced gunsmiths were being conscripted as infantry replacements, their places taken by less skilled workers. This American rifle showed none of that. The receiver was machined from a solid steel forging, not cast or stamped. The tolerances were precision-grade throughout. The gas system components showed sophisticated manufacturing techniques. The walnut stock was properly finished, not the rough wood that German rifles were increasingly using. Every part fit together with the kind of precision that suggested peacetime manufacturing standards, not wartime compromises. Weber spent the entire morning on that first rifle, measuring components, checking tolerances, examining the metallurgy of critical parts. When Oberst Müller checked on his progress around noon, Weber looked up with an expression that Müller had never seen before. Weber said carefully, "I need to fire this weapon before I make my preliminary report. But I can tell you right now, this is not what we expected. This is not crude American manufacturing. This is sophisticated engineering, executed to standards we're currently struggling to maintain." That afternoon, they took all 6 rifles to Kummersdorf's firing range. Weber loaded the first Garand, inserting the 8-round en bloc clip with a metallic click as the bolt slammed forward, chambering the first round. He settled into a prone firing position, acquired his target at 100 meters, and squeezed the trigger. The rifle fired. The spent cartridge ejected automatically. The next round chambered itself. The rifle was ready to fire again in a fraction of a second. No manual bolt operation, no taking your eye off the target, no breaking your firing position. Weber fired the remaining 7 rounds in rapid succession. 8 shots in less than 6 seconds, each one hitting the target. The empty en bloc clip ejected with its characteristic ping, and Weber immediately loaded another clip. 8 more shots. 6 seconds. Reload. 8 more shots. In the time a skilled German soldier with a Karabiner 98K could fire perhaps 12 carefully aimed shots, Weber had just fired 24 rounds from the Garand, and he wasn't even particularly rushed. Müller, watching through binoculars, felt something cold settle in his chest. He'd been in combat. He understood what rate of fire meant on a battlefield. He'd seen what machine guns could do to advancing infantry. But machine guns were crew-served weapons, heavy, requiring multiple soldiers to operate effectively. This was a rifle, a standard infantry rifle, issued to every American soldier, and it could deliver more than twice the firepower of the best bolt-action rifle in the world, while maintaining comparable accuracy. Weber continued testing. He fired from standing positions, from kneeling, from prone. He fired at targets at 200 meters, 300, 400. The Garand performed flawlessly. The gas-operated semi-automatic system cycled reliably every time. The accuracy was excellent, comparable to the Karabiner 98K, but the rate of fire, the sustained rate of fire, was devastating. They tested all 6 rifles over the next 2 days. Different shooters, different ammunition, different conditions. The results were consistent. The M1 Garand worked. It worked reliably. It worked accurately. And it gave a single American rifleman the firepower that would require 2, perhaps 3 German soldiers with bolt-action rifles to match. Müller requested additional personnel for the evaluation. Within 24 hours, they had assembled a team that included not just weapons experts, but infantry officers with combat experience from the Eastern Front, North Africa, and the Western European campaigns. These were men who understood what weapons performance meant in actual battle conditions, not just on testing ranges. Oberleutnant Franz Hartmann had commanded an infantry company at Stalingrad. He'd watched his men engage Soviet infantry at ranges where individual marksmanship mattered. He understood the brutal mathematics of small arms combat. When he fired the Garand for the first time, his hands trembling slightly, not from cold but from the implications of what he was experiencing, he turned to Müller and said something that would appear in the official report. "Sir, if the Americans are issuing these to every infantryman, our current squad tactics are based on assumptions that no longer apply. A single American squad with these rifles can deliver more sustained firepower than a German squad with Karabiner 98Ks, even before we account for their machine guns. We're not just outgunned, we're fighting with an entirely different understanding of what infantry weapons can do." But the team was just beginning their analysis. What they discovered next would transform initial concern into something approaching dread. Over the following days, they would realize the Garand wasn't just a better rifle. It was evidence of a complete revolution in American military thinking, one that Germany had missed entirely. The metallurgical analysis came back on the 3rd day, and it raised more questions than it answered. Hauptmann Dieter Klein, Kummersdorf's chief materials specialist, had cut sample sections from one of the Garand's barrels and several internal components. The results showed steel quality that exceeded German military specifications. High-grade alloys throughout, no evidence of inferior materials substituted to stretch supplies, no recycled steel with unpredictable properties. The Americans were using premium steel for standard infantry rifles, not specialty weapons, not sniper rifles, standard issue equipment for millions of soldiers. Klein calculated the steel requirements. Each M1 Garand required approximately 9 pounds of high-quality steel, not counting the ammunition. German intelligence estimated American production at hundreds of thousands per year. The steel allocation alone represented industrial capacity that Klein found difficult to comprehend. "They're not rationing materials," he told Müller during the briefing. "Look at this receiver, machined from a solid forging. We could make rifles this way. We did make rifles this way, before the war when we had time and resources. But now we're using stamped components, simplified designs, whatever we can do to increase production. The Americans are still manufacturing as if they have unlimited resources." Müller picked up one of the Garands, feeling its weight, its balance. "Maybe they do," he said quietly. The gas operating system represented the most sophisticated aspect of American engineering. Unlike bolt-action rifles, where the soldier manually cycles the action, the Garand used expanding gas from the fired cartridge to automatically operate the mechanism. When the rifle fired, a small amount of gas was diverted through a port in the barrel, driving a piston that cycled the action, ejected the spent case, and chambered a new round. This wasn't a new concept. Various semi-automatic rifles had used gas operation before. But the Garand's system was refined to a degree that impressed even skeptical German engineers. The tolerances were tight enough to ensure reliability, but loose enough to function when dirty. The components were robust enough to withstand sustained use, but light enough to allow rapid cycling. Someone had spent years perfecting this design, eliminating weaknesses, optimizing performance. Oberingenieur Friedrich Kessler, who had designed components for German aircraft weapons, spent an entire day studying the gas system. His conclusion, documented in his technical notes, was stark. This represents perhaps 5 to 10 years of dedicated development work, systematic testing, iterative improvement, comprehensive understanding of gas dynamics and metallurgy. The Americans didn't stumble upon this design. They engineered it deliberately, investing resources that suggest they understood semi-automatic rifles would be important long before the war began. That realization led to deeper questions that troubled the German team more than the rifle's immediate performance. When had the Americans started this development? How had they known semi-automatic rifles would be valuable when everyone else believed bolt-action weapons were adequate? What else had they been developing that German intelligence had missed? The training implications became apparent when they brought in infantry soldiers to test the Garand. Gefreiter Hans Schmidt had been shooting rifles since he was 12 years old. He was a marksman with his Karabiner 98K, capable of consistent hits at 500 meters. They gave him 15 minutes of instruction on the Garand, handed him 3 on-block clips, and told him to engage targets as he would in combat. Schmidt's first magazine was hesitant, uncertain. He wasn't used to the semi-automatic action, kept trying to work a bolt that didn't need to be worked. His second magazine was faster, more confident. By his third magazine, he was putting rounds on target at a rate that would have been impossible with his bolt-action rifle. When he finished, Schmidt looked at the Garand with something approaching awe. "It's easier," he said, surprised by his own conclusion. "The bolt action requires breaking your position, working the bolt, reacquiring the target for every shot. This, you just squeeze the trigger, stay on target, maintain your sight picture, fire again. It's faster, and it's actually less tiring over sustained engagement." They tested a dozen soldiers over the next 2 days. Experienced riflemen, average soldiers, even a few recruits with minimal training. The results were consistent. The Garand was easier to shoot effectively than the Karabiner 98K, and it delivered significantly more firepower. The training advantage was perhaps the most troubling discovery. Germany was losing experienced soldiers at an unsustainable rate. Replacements were receiving abbreviated training before being sent to combat units. The Karabiner 98K was a simple rifle, but effective use still required considerable practice to master the manual bolt operation while maintaining accuracy. The Garand's semi-automatic action reduced the skill threshold for effective use. A partially trained American soldier with a Garand could deliver more effective fire than a well-trained German soldier with a bolt-action rifle. When you scaled that across armies of millions, the implications were staggering. Müller called for a tactical evaluation on the 6th day. They assembled a mixed group, weapons experts, infantry officers with combat experience, tactical instructors from the infantry school. The question they needed to answer wasn't just what the Garand could do, but what it meant for actual combat operations. Major Karl Hoffmann had commanded infantry battalions in Russia. He'd been wounded twice, decorated 3 times, and he understood small unit tactics with the clarity that only combat experience provided. When asked to assess the Garand's tactical impact, he spoke with the directness of someone who had watched too many young soldiers die to waste time on pleasantries. "Firepower determines tactics," he began. "We base our squad organization on the assumption that our MG-34 or MG-42 provides the primary firepower, while riflemen support with accurate but relatively slow bolt-action fire. An American squad equipped with Garands changes that calculation fundamentally. Their base of fire from rifles alone exceeds what we can deliver from our entire squad, even before accounting for their machine guns." He gestured to the Garand lying on the table between them. "Consider a meeting engagement at 200 meters, standard infantry contact distance. Our squad puts down suppressive fire, perhaps 90 to 120 rounds per minute from all 8 riflemen combined. Their machine gun adds 500 to 700 rounds per minute. That's our standard tactical doctrine, and it works because we can concentrate overwhelming firepower when needed." Hoffman paused, his scarred hands clenching slightly. "An American squad with Garands can deliver perhaps 200 rounds per minute from their riflemen alone, sustained. Add their machine gun, and they're putting down nearly 1,000 rounds per minute. They don't just outshoot us, they fundamentally change the tactical equation. Maneuvers that work against Soviet or British infantry, where everyone has bolt-action rifles, become suicide against Americans with Garands." The room fell silent as the officers absorbed this assessment. These weren't theoretical calculations. This was combat mathematics from someone who had lived it. General Major Kurt Fischer arrived at Kummersdorf on November 14th, summoned by reports that had reached the Army High Command through channels that suggested something significant had been discovered. Fischer was not a technical officer. He was a combat commander who had led infantry divisions through Poland, France, and now Russia. He understood weapons in terms of what they did on battlefields, not in terms of engineering specifications. Müller briefed him personally, walking Fischer through the testing results, the metallurgical analysis, the tactical assessments. Fischer listened in silence, his weathered face showing no emotion. When Müller finished, Fischer asked a single question. "Show me what this means in practical terms. No technical specifications. Show me what this rifle does to my infantry." They arranged a demonstration that afternoon. 2 squads of experienced infantry, one equipped with Karabiner 98Ks, the other with the captured Garands. Standard tactical scenario, engaging targets at varying ranges while advancing across open ground. Both squads had been briefed on the exercise. Both were motivated to perform well in front of a general officer. The squad with bolt-action rifles performed exactly as expected. Disciplined fire, proper movement techniques, coordinated advances. They were good soldiers using good weapons effectively. They completed the course in 8 minutes, achieving 73% hits on target. The squad with Garands completed the same course in 5.5 minutes, with 87% hits on target. The difference wasn't that they were better soldiers. It was that they could maintain sustained fire while moving, could engage targets without breaking their stride to work a bolt, could suppress enemy positions with volume of fire that bolt-action rifles simply couldn't match. Fischer watched in silence. When the demonstration ended, he walked to where the Garand-equipped squad was standing, breathing hard from their exertion. He picked up one of the rifles, felt its weight, worked the action. "How long did it take you to learn to use this?" he asked the squad leader. "Perhaps 30 minutes of instruction, Herr General," the Feldwebel replied. "The weapon is simpler to operate effectively than the Karabiner. The automatic action means we can focus on target acquisition rather than manual cycling." Fischer handed the rifle back and turned to Müller. "I need to see your complete analysis, all of it. And I need intelligence estimates on how many of these the Americans have produced." The intelligence briefing came 2 days later, and the numbers transformed concern into crisis. American production of the M1 Garand had begun in 1937 at Springfield Armory. By 1941, they had ramped up to approximately 50,000 rifles per year. After Pearl Harbor, they had expanded production to Winchester and eventually other contractors. Current estimates suggested production of over 500,000 M1 Garands per year, with capacity still increasing. 500,000 per year. That meant the Americans were producing enough Garands in 12 months to equip 50 infantry divisions. Germany's entire army consisted of roughly 250 divisions at peak strength, and most of those were not infantry divisions. The Americans were producing sufficient semi-automatic rifles annually to equip 1/5 of the entire German army, and they were just getting started. But the numbers got worse. Intelligence indicated the Americans had begun M1 Garand production in 1937, 5 years before Germany invaded Poland, 2 years before anyone expected a general European war. The Americans had seen the future of infantry combat while everyone else was still fighting the last war. Fischer did the calculations that evening, sitting alone in his quarters at Kummersdorf. By the end of 1943, the Americans would likely have produced over 3 million M1 Garands. They were equipping not just their infantry divisions, but their airborne troops, their Rangers, their Marine Corps. Every American rifleman would have a weapon that gave him firepower superiority over any German infantryman with a bolt-action rifle, and here was the truly devastating part. There was nothing Germany could do about it. They didn't have a semi-automatic rifle in production. They had experimental programs, the Gewehr 41, the Gewehr 43, but these were limited production runs, specialist weapons issued to perhaps 1 soldier in 10. The manufacturing capacity, the tooling, the design refinement, all of it would take years to develop and implement. Years they didn't have. Even if Germany somehow started producing semi-automatic rifles tomorrow, they would still be years behind American production numbers. The Germans would be fighting with bolt-action rifles against semi-automatic rifles for the foreseeable future, and there was nothing anyone could do to change that equation. One of the officers at the briefing, a major whose name was redacted from the declassified documents, stood up and asked the question everyone was thinking. "So what do we do? How do we counter this?" Fischer looked at him for a long moment before responding. "We don't counter it. We can't counter it. We adapt our tactics to minimize our disadvantage, we increase the quality of our training to partially compensate, and we pray that German engineering can find solutions to problems we're only now beginning to understand. But counter it? No. That ship sailed in 1937 when the Americans started producing these rifles, and we were still convinced bolt-action weapons were adequate." The tactical analysis that followed over the next week painted a picture of infantry combat that challenged fundamental German doctrine. Since the beginning of the war, German infantry tactics had relied on fire and maneuver, with squad-level tactics built around the machine gun as the primary firepower element. Riflemen provided supporting fire, but the MG-34 or MG-42 was what won firefights. This doctrine worked brilliantly when everyone had bolt-action rifles. German machine guns were arguably the best in the world, with rates of fire that exceeded anything the Allies fielded. A German squad might be outgunned in rifles, but the machine gun superiority provided the edge needed for tactical success. The M1 Garand disrupted this calculation completely. An American squad still had fewer machine guns than a German squad, but their combined firepower from rifles and machine guns exceeded what German squads could deliver. The tactical advantage that German machine guns provided was being overwhelmed by sheer volume of fire from American semi-automatic rifles. Major Hoffman prepared a detailed tactical memo that would later be distributed to infantry commanders across all theatres. His conclusions were stark. Against American troops equipped with M1 Garands, German infantry could no longer rely on traditional fire and maneuver tactics at typical engagement ranges. The Americans could put down suppressive fire that forced German soldiers to keep their heads down, reducing their ability to return effective fire, while American units maneuvered for advantage. German squads needed to either engage at longer ranges where marksmanship mattered more than rate of fire, or close to ranges where grenades and submachine guns neutralized the Garand's firepower advantage. The middle distances, 200 to 400 meters, where most infantry combat occurred, had become deadly ground for German soldiers facing Americans with Garands. The memo included a chilling statistical projection. In equivalent tactical situations, German infantry casualties were likely to increase by 25 to 40% when facing Americans with M1 Garands, compared to enemies equipped with bolt-action rifles, assuming all other factors remained equal. That wasn't speculation. It was mathematical projection based on firepower analysis and combat experience. 25 to 40% higher casualties. Across an entire army, across years of warfare, that translated to hundreds of thousands of additional German soldiers killed or wounded, simply because the Americans had developed a better rifle and Germany had not. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The comparison to other theatres became unavoidable. German soldiers had faced Soviet infantry equipped with bolt-action Mosin Nagants and some SVT-40 semi-automatic rifles, but the Soviet semi-automatics were issued in limited numbers and had reliability problems. They faced British infantry with Lee Enfield rifles, excellent bolt-action weapons but still manually operated. They faced French, Italian, Polish, and countless other armies, all equipped with bolt-action rifles. In every case, German infantry tactics, German training, and German firepower had been sufficient to achieve tactical success more often than not. Individual battles might be lost, strategic objectives might fail, but at the squad and platoon level, German infantry could generally hold their own or better against any opponent. The Americans were different. They had industrialized infantry firepower in a way no one else had attempted. They had recognized that semi-automatic rifles weren't just nice to have, they were transformational, and they had committed the resources necessary to equip their entire infantry force with these weapons years before anyone else thought it was necessary. Oberleutnant Hartmann, the Stalingrad veteran, put it most clearly in his section of the analysis. We trained to fight the last war. We perfected bolt-action rifle tactics, developed machine gun doctrine, created infantry formations optimized for warfare as we understood it in 1939. The Americans looked ahead and asked what infantry combat would become. They answered that question with the M1 Garand, and now we're fighting tomorrow's war with yesterday's weapons. The psychological impact on the German officers conducting this analysis was profound. These were professionals who had dedicated their lives to military service. They had trained extensively, fought bravely, and believed in German military superiority based on years of success. And now they were confronting evidence that their entire understanding of infantry combat was obsolete. Several post-war accounts from officers involved in the Garand evaluation described it as a breaking point in their confidence. Not a collapse, these were still dedicated soldiers, but a fundamental shift in how they understood Germany's strategic position. If the Americans had leapfrogged German infantry weapons development this completely, what else had they developed that German intelligence hadn't discovered yet? The material analysis revealed another troubling dimension. The M1 Garand wasn't just better than German rifles, it was easier to manufacture at scale than it appeared. The Americans had designed the rifle with mass production in mind. Components were designed for machining rather than hand-fitting. Tolerances were tight enough for reliability, but loose enough for high-volume manufacturing. The design showed evidence of systematic production engineering, not just weapons design. This suggested the Americans understood something that German industry was still struggling with. You didn't just design a superior weapon. You designed a weapon that could be manufactured in millions without sacrificing quality. The M1 Garand represented the intersection of weapons, design, and industrial engineering, and the Americans had mastered both simultaneously. Oberingenieur Kessler's final technical report included a section that became famous in post-war analysis. The M1 Garand demonstrates American thinking about warfare that differs fundamentally from European approaches. Where we emphasize individual craftsmanship and precision, they emphasize systemic excellence and scalable production. Where we create superior individual weapons, They create adequate weapons in overwhelming numbers. Where we solve problems through engineering refinement, they solve problems through industrial capacity. The tragedy, Kessler continued, is that the M1 Garand is not an adequate weapon. It is an excellent weapon. They have achieved both quality and quantity simultaneously, demonstrating industrial and engineering capabilities that we cannot match. This rifle is not evidence of American luck or resource advantages. It is evidence of systematic American superiority in understanding how to fight industrial wars. That passage would haunt German military thinking for the remainder of the war. Not because it was defeatist, but because it was accurate. The officers reading it knew Kessler was right. They had seen the evidence firsthand. The Americans weren't just winning through numbers. They were winning through better understanding of what modern warfare required. Fischer's meeting with Army High Command occurred on November 23, 1942. He brought Müller and several other officers from the Kummersdorf evaluation team. They presented their findings to a room full of senior officers, many of whom had not yet grasped the implications of American semi-automatic rifle production. The presentation took 3 hours. They showed firing tests, tactical demonstrations, manufacturing analysis, intelligence estimates on production numbers. They explained how the M1 Garand changed squad-level tactics, increased American firepower, and reduced the effectiveness of German infantry doctrine. They projected casualty rates and assessed strategic implications. When Fischer finished, the room sat in silence. Finally, one of the generals spoke. "Surely we can develop countermeasures. Improved tactics, better training, our own semi-automatic rifles." Fischer looked at him directly. "Herr General, the Americans started developing this rifle in the early 1930s. They began production in 1937. They have manufactured over 1 million rifles and are producing 500,000 more per year. We have experimental programs that might, if everything goes perfectly, produce limited numbers of semi-automatic rifles in 1944 or 1945. By then, every American infantryman will have had a firepower advantage over our soldiers for years." He gestured to the captured Garand lying on the table. "This is not a problem we can solve. This is a reality we must accept." The Americans understood the future of infantry combat before we did, and they invested the resources to get there first. Our tactical manuals, our training programs, our entire infantry doctrine is based on assumptions that are no longer valid. We can adapt, we can improve, but we cannot eliminate the fundamental firepower disadvantage our infantry faces against American troops. Another general asked the question Fischer had been dreading. What about the Eastern Front? Are the Soviets developing similar weapons? Soviet semi-automatic rifles have had reliability problems, Müller answered. Their SVT-40 is issued in limited numbers, perhaps 10 to 15% of their infantry. But they are producing it, and Soviet industry learns quickly. If they solve their reliability issues and scale up production, we could face the same firepower disadvantage on the Eastern Front within a year or two. The implications settled over the room like a physical weight. Germany was already fighting a multi-front war against enemies with superior industrial capacity. Now they were learning that one of those enemies had weapons superiority that German industry couldn't quickly match. The strategic picture that had seemed difficult but manageable suddenly looked far more grim. Fischer ended his presentation with a recommendation that appeared in the official minutes. We need immediate revision of infantry tactical doctrine to address American firepower superiority. We need accelerated development of our semi-automatic rifle programs, understanding we are years behind American production capacity, and we need honest assessment of our strategic position, because if the Americans have achieved this level of superiority in infantry rifles, we must assume they have similar advantages in other areas we haven't yet discovered. That last sentence proved prophetic in ways Fischer couldn't have imagined. Over the following years, German forces would discover American superiority in artillery, in logistics, in communications equipment, in vehicles, in virtually every category of military hardware. But the M1 Garand was the first clear evidence that the Americans weren't just producing more equipment, they were producing better equipment, at scales Germany couldn't match. The psychological impact on German soldiers who actually faced American infantry was documented in numerous after-action reports and prisoner interrogations. German infantrymen quickly learned to recognize the distinctive sound of M1 Garand fire. The steady, rapid crack of semi-automatic fire was different from bolt-action rifles, and it signaled an enemy who could put down sustained firepower that German squads couldn't match. One Unteroffizier captured in Italy in 1944 told his interrogators something that appeared in multiple intelligence reports. You could tell when you were facing Americans by the sound. Soviet soldiers had bolt-action rifles like ours. British soldiers had bolt-action rifles. But Americans, they had those semi-automatic rifles, and when they opened fire it sounded like machine guns. You couldn't raise your head. You couldn't return effective fire. You just had to keep low and hope your own machine guns could suppress them enough to maneuver. The tactical adaptations German infantry made were documented in revised field manuals issued throughout 1943 and 1944. Squads were instructed to engage American infantry at longer ranges where accurate aimed fire mattered, more than rate of fire. They were told to close quickly to ranges where grenades and submachine guns neutralized the Garand's advantage. They were taught to maximize use of cover and concealment because American firepower made movement under fire more dangerous than against opponents with bolt-action rifles. These were sensible tactical adaptations, and they reduced German casualties to some degree. But they were fundamentally defensive measures, attempts to minimize disadvantage rather than achieve advantage. German infantry doctrine had always emphasized aggressive action, fire and maneuver, seizing initiative. Against Americans with M1 Garands, German soldiers were being taught to be cautious, to avoid certain tactical situations, to work around their firepower disadvantage rather than exploit firepower superiority. This shift in tactical thinking had profound effects on German infantry effectiveness. Soldiers who had been trained to attack confidently were now being told to be careful, to respect enemy firepower, to understand they were outgunned. That kind of psychological shift affects unit cohesion and combat effectiveness in ways that are difficult to quantify but impossible to ignore. The development efforts for German semi-automatic rifles accelerated after the Kummersdorf evaluation, but they faced obstacles that American designers had overcome years earlier. The Gewehr 41 had reliability problems and was never produced in significant numbers. The Gewehr 43, introduced in 1943, was better, but still issued only to designated marksmen and specialists, perhaps 1 or 2 per squad. Even at peak production, Germany never manufactured more than a few 100,000 semi-automatic rifles total. The Americans had produced millions of M1 Garands by the time the war ended. The firepower gap that existed in 1942 never closed. It widened as American production continued, while German industry struggled to replace losses and maintain even basic equipment levels. The captured M1 Garands that sparked this evaluation were eventually destroyed, most likely during Allied bombing raids on German testing facilities. But their impact extended far beyond their physical existence. They had revealed a truth that German military leaders couldn't ignore or rationalize away. The Americans had fundamentally changed infantry combat, and Germany had missed it entirely. Post-war interviews with German officers involved in the evaluation revealed the lasting psychological impact. Fischer, interrogated by American intelligence officers in 1946, was asked when he knew Germany would lose the war. His answer was immediate. November 1942, when I examined the M1 Garand and realized what it meant. Not that we couldn't win individual battles. We continued winning tactical engagements throughout the war. But the strategic trajectory was clear. The Americans understood modern warfare better than we did, and they had the industrial capacity to implement their understanding at scale we couldn't match. Müller, in his post-war testimony to British intelligence, described the Garand evaluation as the moment our confidence broke. He elaborated, "We had believed, truly believed, that German military technology and tactical doctrine were superior, that our soldiers were better trained, our officers more competent, our weapons more effective." The Garand evaluation forced us to confront evidence that contradicted all of those assumptions. The Americans had outthought us strategically, out-engineered us technically, and outproduced us industrially. And they had done it years before we recognized there was even a competition. The broader lesson of the M1 Garand evaluation extended beyond infantry weapons to fundamental questions about how modern wars are fought. And 1. The Germans had approached World War II with assumptions rooted in World War I experience. They had refined existing technologies, improved proven doctrines, and created an efficient military machine based on conventional understanding of warfare. The Americans had looked at the same history and asked different questions. What if infantry combat evolved beyond bolt-action rifles? What if semi-automatic weapons became practical for mass issue? What if industrial capacity could produce both quality and quantity simultaneously? They had invested in answering those questions years before the war began, and by the time shooting started, they had solutions their enemies hadn't known were needed. This pattern repeated across multiple domains. While Germany refined existing tank designs, America developed the Sherman and produced it in numbers that overwhelmed German armor, despite individual German tanks being superior in direct combat. While Germany created excellent artillery pieces, America developed coordinated fire control systems and produced enough artillery to provide overwhelming fire support. While Germany built sophisticated aircraft, America produced simpler designs in quantities that achieved air superiority through numerical advantage, combined with adequate performance. The M1 Garand wasn't unique, it was representative. It showed how America approached industrial warfare differently, emphasizing scalable solutions over perfection, understanding that good enough equipment in overwhelming quantities often beats excellent equipment in limited numbers. German engineering was genuinely exceptional throughout the war. The MG-42 machine gun was arguably the best squad automatic weapon of the entire war. German optics were superior. Tank designs like the Panther and Tiger were formidable. Jet aircraft development was years ahead of Allied programs. German engineers consistently demonstrated innovation and technical excellence. But engineering excellence without adequate industrial capacity produces fascinating prototypes and limited production runs, not strategic advantage. The Americans had both good engineering and massive production capacity, and that combination proved decisive. By 1944, the firepower gap between American and German infantry was visible in every engagement. American squad tactics assumed every rifleman could deliver sustained semi-automatic fire. German tactics still worked around the limitation that most soldiers had bolt-action rifles. American infantry could suppress German positions with rifle fire alone, allowing maneuver and assault. German infantry needed machine gun support for suppressive fire, making their tactics more dependent on crew-served weapons. The casualty statistics, while difficult to compare directly due to varying record-keeping and battlefield conditions, suggested the tactical assessments from Kummersdorf had been accurate. German infantry facing American units took higher casualties than when facing British or Soviet infantry, even accounting for air support and artillery differences. The M1 Garand wasn't the only factor, but it was a consistent advantage that shaped every infantry engagement. Perhaps most tellingly, after the war, German officers consistently cited the M1 Garand as one of the most significant American advantages. When asked what surprised them most about American military capability, the semi-automatic rifle appeared repeatedly in their responses. They had expected American industrial strength. They had anticipated numerical superiority. But the M1 Garand represented something they hadn't predicted, that American equipment would be not just numerous, but genuinely superior in practical battlefield performance. The M1 Garand continued serving American forces through the Korean War and into the early years of Vietnam. By the time it was replaced by the M14 and eventually the M16, over 5.5 million had been produced. General Patton's assessment that it was the greatest battle implement ever devised reflected not just the rifle's performance, but what it represented about American military thinking. The Garand symbolized an approach to warfare that emphasized giving every soldier a technological advantage, not just elite units. It showed American willingness to invest in weapons development years before war began, rather than waiting for conflict to drive innovation. It demonstrated industrial capacity that could produce sophisticated equipment at scales that seemed impossible to observers from less industrialized nations. For the German officers who evaluated those 6 captured rifles in November 1942, the M1 Garand was a revelation that shattered comfortable assumptions about German military superiority. They had entered that evaluation expecting to confirm their beliefs about American weapons being crude but effective. They left understanding that American weapons were sophisticated and effective, produced by an industrial system that operated at scales Germany couldn't match. The 6 M1 Garands that arrived at Kummersdorf in November 1942 carried a message their original users never intended. They announced that the Americans had changed the rules of infantry combat, and everyone else was playing by outdated rules. They proved that industrial capacity, combined with intelligent engineering, created advantages that tactical brilliance and individual courage couldn't overcome. They demonstrated that wars are not just fought by soldiers, but by economic systems, industrial infrastructures, and strategic thinking that looks years into the future. Those German officers who walked out of Kummersdorf after completing their evaluation carried a terrible burden of knowledge. They had seen the future of infantry combat, and it belonged to America. They would continue doing their duty, training soldiers, improving tactics, supporting their units. But they knew. The Americans had changed everything, and there was nothing Germany could do to change it back. Modern audiences sometimes forget how revolutionary the M1 Garand was when it appeared. We're used to automatic and semi-automatic weapons. Every military rifle today fires multiple shots without manual operation. But in 1942, the M1 Garand was cutting-edge technology that only one nation had successfully fielded to its entire infantry force. The Germans recognized this immediately when they had the chance to examine it carefully. They understood they were holding evidence of American military and industrial capability that exceeded their worst estimates. They knew what it meant for their infantry, for their tactical doctrine, for their strategic position, and they knew there was nothing they could do about it. Some of you watching this might have a grandfather or great-grandfather who carried an M1 Garand during World War II. Maybe he landed at Normandy with that rifle, or fought across France, or island-hopped in the Pacific. He probably never thought of his rifle as a revolutionary weapon. It was just his issued equipment, what every other American soldier carried. He cleaned it, maintained it, fired it when necessary, and trusted it to work when his life depended on it. But that rifle represented years of American engineering development, millions of dollars in research and production investment, and a strategic vision that looked beyond conventional wisdom to imagine how infantry combat might evolve. Your grandfather was carrying not just a weapon, but the culmination of American industrial and engineering excellence, produced by workers in factories who took pride in building equipment that American soldiers would depend on. Those workers at Springfield Armory, at Winchester, at all the contractors who produced M1 Garand components, they probably never knew that their attention to quality and precision was breaking the morale of enemy officers who examined their work. They clocked in, did their jobs well, and went home, but they were winning the war in ways that soldiers on battlefields never saw. They were building weapons so good that enemy officers calculated defeat just by measuring them. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.